Nanotechnology has been moving a little faster than I expected. Virtual reality a little slow. A very good evening to all the guests and dignitaries. I feel delighted to extend a warm greetings to all of you for today's webinar on nanoscience and nanotechnology, the domain of infinite research on the behalf of DIGISAKSHAM. I, Vandana Garg, your host of the day, extend a warm welcome to all of you. Before I go further, I would like to take a moment to introduce my organization. DIGISAKSHAM is an initiative of Science Group which has developed content for over 300 courses in multiple languages which range from 4 hours to 6 months in various sectors of IT, BFSI, retail and entrepreneurship for all age groups from school children, youth, professional and senior citizens. DIGISAKSHAM has also conducted more than 150 webinars, 10 plus FDPs and workshops and 7 plus international conferences. DIGISAKSHAM impacted more than 20,000 lives through various webinars, conferences, workshops, and seminars across the globe. The topic for today's webinar is nanoscience and nanotechnology, the domain of infinite research. Nanoscience is a convergence of physics, material science, and biology, which deals with manipulation of material at atomic and molecular scale, while nanotechnology is the ability to observe, measure, manipulate, assemble, control, and manufacture matter at a nanometer scale. I am profusely elated to take an opportunity to introduce our chief guest of the day, Dr. Sambhavi Katyayan Mishra. Dr. Sambhavi Katyayan Mishra is currently an assistant professor of physics in Faculty of Education and Methodology in Jyoti Vidyapeeth Women's University, Jaipur. Being an eminent academician, she is also actively involved in research in nanoscience and material physics. Her research interest includes nanomaterials processing, characterization, study of opticals, thermal, and electrical properties of nanomaterial, TL mapping, etc. She has published 14 SCI papers in reputed international journals. Besides this, she also actively participated and attended numerous workshops, webinars, short-term training programs, and conference papers. She has also published a book titled Optical Characteristics of Rare Earth-Activated Perovskite Phosphors. The world is full of diamonds and gems. We are having one of them here today to build this event. With this note, I would like to give my heartiest welcome to our guest speaker of the day, Dr. Sambhavi Katyayan Mishra ma'am, with a big round of applause. Before going further, I request all the participants to remain mute throughout the webinar. And if anybody is having any doubt, they can type in the chat box or you can also raise your hand. Now, I request ma'am to please take charge.
Thank you, Vandana, for this wonderful introduction. And first of all, I would like to thank SEM and DIGISAKSHAM for creating such a wonderful platform for intellectual to share their knowledge with people from multidisciplinary research domain, because it is always good to have such interaction. So now coming to my topic, nanoscience and nanotechnology, the domain of infinite research and innovation. If I say this word infinite, itself can summarize that no talk, no discussion is sufficient enough to discuss this topic. This topic is beyond the timeline, but it is so interesting and there is so much scope of going for further research that I am very happy to share my share of knowledge with everyone. So basically, my work is on nanomaterials and we worked on specialized nanomaterials. So I'm going to share some important things about them. First of all, what we call as nanomaterial is basically any particle that lies within the size dimension of 100 nanometer. So we are basically studying them in one-dimensional, two-dimensional, three-dimensional architectures. And what we are basically focusing is there are different physical, chemical properties or structural differentiation in these nanomaterials, which they make them very interesting for research purpose, for applications, because a small variance in their dimension or in their synthesis can bring a lot of changes. Okay, so this term nano was actually, it is a Greek word that was actually stand for DOF, the one which is short height. So actually we're talking about the materials that are very short heighted if we talk about the dimension part. So this term was coined, and all this nanoscience and technology focuses on the synthesis, like we are processing them in our lab, and how we are using them for application purpose. So we are actually dealing with all those things. Moving ahead, if I say what was interesting when you think about or when you discuss about nano, you cannot miss what was said by Richard Feynman in one of his very famous lecture in 1960. He has said a line that there is a plenty of room at the bottom, and this line was sufficient enough to introduce nanomaterials, because if you are talking about nanomaterial, you have a lot to learn, a lot to research, a lot to innovate. There is a lot of scope. He's basically quoting that scope of research and innovation in this one line, that there is a plenty of room at the bottom. And this was very interesting, because at that time in 1960s, he was able to actually get a foresight of this very big research innovation field. So beginning with his idea, so first of all, I will discuss about the types of nanoscales we have if we characterize them dimensionally. So we have 0 dimension, where we talk about nanopowder and quantum dots. Okay. Then comes 1 dimensional, where we have nanorods. Carbon nanorods, you must have heard, many of you have heard carbon nanorods, or you have heard about nanowires, nanotubes. These are specially synthesized 1 dimensional nanomaterials. Then comes nanosheets and superlattices, that comes in 2 dimensional architecture. And then very famous one, the 3 dimensional architecture, most of us have studied in our school, buckyball C60. If you have remembered this assembly of 60 carbon atom, it gives a shape, a buckyball shape. Okay, so it is very famous, this 3 dimensional nanomaterial. So this is also coming when we are talking about nanoscales. Now, there are 2 type of processes of synthesizing nanomaterials or preparing them in our lab. And these 2 approaches are top down and bottom up. Now, the name itself, I think, is sufficient enough to tell that in first approach, top down, we are basically we are differentiating, or we are disintegrating the bulky material to get the nanoparts. And in the second approach, bottom up, we are assembling the nano or the small dimension ones together to get the bulk. So we have small nanostructures and we have bulk nanostructure also. So basically that is discussed by these 2 approaches. Then comes the nanomaterials, okay, and their application. Like there are so many interesting applications. So in application, if you see, they have moved from labs or from industries to our household. Like in our daily life, we are using so many devices, so many things that have nanomaterials. Okay, so I'm discussing a few of them here. Electroluminescent screen that you have in the display panels. Okay, they are also using specialized nanomaterial, which is luminescent in nature, electroluminescent in nature. Then we have fluorescent lamp, the CFLs that we are using. Okay, every household have it. Then we have LEDs. Now LEDs, earlier LEDs were only used for this indicator and all these purpose in labs only, but now it is there in your household. You have lightings using these LEDs. Then tomography. If I say medical field, then tomography is just like X-ray. You are recording the body part or the image of that organ, and then you are keeping it preserved, conserved, and that image is reconstructed because it is taken on specialized nanomaterial panels. Then comes sensors. Now sensors, even your mobiles that we are using, and they are giving you the weather report, or they are telling you the temperature. So all this is sensors. They have specialized sensors. Because of them, they are giving you the data of your surrounding. Okay. Then comes luminescent paint. This is very interesting. These paints, they are the one which give visible light emission whenever you are supplying energy to them. Okay, so it's like if you are painting a wall, if behind me this curtain I'm having and I'm painting it with the colors, luminescent color, these luminescent color will light up when there is a specialized condition, or they will light up in night. So this looks very good, like in night when there is no light, I can see the curtain because it is painted with luminescent paint. So these are some interesting applications. See, here I was telling you about the paintings using the specialized nanomaterials. So you can see they have painted car, and this car they have painted in daylight. So in daylight it looks like a normal car, but in night you can see how beautiful it is looking. Then the tree is painted, and then this is a very famous painting which is there in the display in a famous gallery, where the painter has used only luminescent paint, and he has actually painted the city look, the entire city look, these big skyscrapers. He has painted them, and then this painting particularly glow in night. So this is said to be a daylight painting, but it glow in night, and it is very beautiful. Then moving ahead, now I have said about luminescent paint. So luminescent paint, first of all, we need to know what is luminescence, because it has a characteristic associated with nanomaterial. There are special nanomaterial that are luminescent nature. So luminescent is like whenever you are giving energy. For example, I have a sheet and I apply pressure on it. Now pressure is a form of energy that I'm supplying, like I'm applying. And what I'm doing is, with this, the panel or that sheet will give me a display, an emission of visible light. So I can use the panel for application purpose. So this is luminescent. That means whenever you are supplying any type of energy, what you will get is, you will get a display of visible light or any specialized emission, UV, IR. It just depend upon the characteristic of the material you are using, because chemical characteristic matters a lot. Then fluorescent and phosphorescent paint we are having. So it depends upon like which type of glow or which frequency they are showing in the emission, that distinguish them for fluorescent and phosphorescent paint. So phosphorescent paint is said to be having a long lasting glow. Okay, like fluorescent is small time glow, and phosphorescent is long time glow. So for example, if I paint a house and it stores energy in daytime, it can light up in even night. Okay, as the sunlight is cutting off, or we are getting the sunlight light stopped, then it starts glowing. Okay, so then it glows, and it glows for a long time. So it's a long lasting emission of light, or you can say a long lasting glow. See, this is how, like, you can paint the library book, specialized that section of their title, you can paint it with luminescent paint, and in night you can see each book of your cabinet is showing its name. Okay, as if there is a light placed on it. So it will that part will glow, and you will read the name. So it is just an attempt of having a library which doesn't need a light in the night. Okay, then this painting, you can see there are so many, like in foreign we can see this happening more. They are painting the wall, and then they are seeing the night emission or night glow, which looks very good. In daytime it looks like just a normal wall, a white wall, but in night it will glow and it looks very beautiful. So this is about the luminescent paint. These are made of specialized nanomaterial. Radium paint also we are having, radioluminescent paint also we are having. So radioluminescent means radionuclide we have used. Okay, any material which is radioactive in nature. So it is used, and what we are getting is radioluminescent paint. Then radium paint is very old. You have heard about the radium watches also, the watches that glow in dark. Okay, and it was a fantasy for many of us in our early teenage or in our young days. Many of us have those radium paint watches. Okay, so those watches are also having the same concept, and specialized materials are used for that. Now, see, this painting, I told you they are painting, and it's like light on, it's a white wall, and when light is off, it shows this beautiful painting. So it looks very beautiful, and they are painting all architecture. They are painting walls, they are painting the car, the trees, and then there's you can see how it looks beautiful. So they are using nanophosphor, or a luminescent paint which is made up of nanophosphor. That nanophosphor is kept on the walls. It is painted, and then you see this beautiful glow at the night. Now, this is very interesting and my personally favorite one, which I'm sharing here. See, we can use like specialized nanomaterial. For what purpose we can use them? For security purpose. Now, see, every currency, it has some marks or some security uh, codes are there, which can be read in specialized light or under specialized conditions only. So we can use specialized ink to write these security codes. And when you are glowing it in ultraviolet or in IR cabinet or in any other cabinet or another different condition, you can read those codes. So this will help us a lot, because in normal vision, in daylight or in invisible light, you will just see the currency. It is as it is. Okay, normal currency, there is no difference, but the security codes are there. Those security codes can only be read when you are placing them, for example, under UV emission. Under in a UV cabinet, when you are placing your currency, you will read the codes. So it is very interesting. See, you can distinguish between a fake currency and original currency with the help of these codes. So it is very, very interesting. If we keep this in our mind as an application, then I find it personally my favorite and very interesting application. And with this, it is very easy for us to have a grip on black money or fake currency, or the currency smuggling can be stopped, because there are the security codes now are more secured in the case of such a specialized ink. Okay, beside that, there are many official documents that are very, very important or confidential. You can write them in with these specialized ink, and they can be read under special conditions only. You can, like, normal person can't read it. So just it's so interesting that it can be read only under specialized condition, and this is known to the people who are connected or in the hold of this confidential. Okay, only they know it. So it's another way of protecting your data, protecting your information, confidential information. And then now nanomaterials can be used for capturing the pictures, like pictures in the sense when you are developing the medical images. Okay, or you are developing some type of molecular imaging. Okay, there you can use these nanomaterials. So you can use specialized panels. There are specialized panels that can be used, and these panels are able to record the data, whatever data you want to record. They are able to record the data, and beside apart from recording, you can conserve the data, you can reread it, because the condition is same. For rereading any phosphor written script, what you need is you have to supply energy from outside, whatever be the form of energy. It could be a mechanical energy, it could be a thermal energy, like with heating you can develop the data. So it's like holography has three stages. If we talk about holography, it has three stages. What are the stages? We are recording the data, we are conserving it, and we are reconstructing it. Similarly, for these specialized plates of specialized nanomaterial, you can capture the image, you can preserve it or conserve it, and you can develop it according to your need whenever you want it. Okay, according to your need, you can keep the data intact how long you want. Now, moving ahead, now this is interesting. Cosmetics, they're having these nanomaterials, and we all know it. Like most of these creams that we are using having titanium dioxide as one of the constituent, and it is synthesized by high temperature technique in the lab, and this is used as one of the important component of your cosmetics. So you can understand, like, from laboratories, from research centers, or from industries, now this nanomaterial has entered in our day-to-day life. Like, you have lightings, you have cosmetics, you have so many appliances, you have your display panels, and even if I talk about the currency also, you have your currency where the ink is a nanomaterial specialized ink, security ink. Okay, so you can say, like, everywhere nanomaterial has made their place and they have their grip. So they are becoming an important part of our life, and it is very interesting to see how every different aspect of application is connected with this interesting category of materials. Now moving ahead, see, as I was discussing about these lighting, night lighting or specialized lighting material, so you can see the nail paints, okay, luminescent nail paint. Now, don't get confused that luminescent material only give glow in night. No, I'm talking about some of the interesting material, because night glow is something which is very interesting. It sounds interesting, but they can glow in daylight also. Okay, all they need is when you are supplying energy from outside, the material will give you a visible light or a specialized light emission. It could be a UV also, it could be an IR also, but a specialized emission is obtained. Okay, so you have these nail paint. You can see how glittery and this luminescent paint they are. They show this glow, and this material actually, when you are getting this visible light glow, we are basically using, in most of the cases, we are using rare earth. Now, if you have an idea about the periodic table is showing a group of specialized material, lanthanides, that forms the rare earth. Okay, like there are 14 lanthanide, and there are some addition to them, yttrium, scandium, all these are there, and lanthanum is there, so all three are addition to them. So those specialized rare earth, we are using them as a doping to our constituent, to our host, and then we are preparing a material which can give you a desired emission. That desired emission could be of any form, like you can get red light emission, green, blue, or multiple, like it could be a monochromatic single color, or it could be of many light, like many chromes together or many wavelengths together. So same material can give different characteristics. Only you have to vary the doping or the doping constituent, you have to vary, because that amount is very important, how much doping you are doing. So this I'm discussing because I have prepared these materials in my lab. I worked on nanophosphor, and the light giving phosphors we have prepared in our lab, and we have studied their properties, we have seen the emission, we have studied how their dimension and their constituent, like how the um, initial this doping constituent or percentage, when you are varying it, you will see a distinction in their behavior, you will see a variation in their behavior. The light emission also varies. Okay, now moving ahead, okay, this is very interesting. The goggles and binoculars that we are using, they also make use, like our military and security people are using, they are also using specialized phosphor plates, okay, or phosphor sheets. Now this I just want to tell you, see, what is the problem when it comes to vision in night time is that it is complicated to see with clarity, because there is lack of sunlight. What we'll see is because of the sunlight, and in, for example, you are in forest and you are doing some secret mission, it is very difficult for you to have a vision, proper vision, to distinguish between to locate your path, or to distinguish between tree and path, and there are other things. Okay, so this visibility issue is a big problem. Now what can be done here is that you can resolve this problem if you are capable enough in getting a enhanced vision. Okay, enhanced vision is a clarity of your vision. When you are looking up anything, when you are, for example, you are using your specialized binocular or goggles to look for the path, there you will see an enhanced vision, a more clarity, or you will see things more clear. Now, how this can be done? This can be done using specialized material that could up convert. Okay, so up convert in the sense you are getting diminished amount of light or quantum count, and then what happened is that because of the photo multiplier and the phosphor that you are getting, you that you are using, you are getting an enhanced vision. Okay, So the earlier it was dark for me when I am looking at the path. The path was not clear, it was dark for me. But then what happened is I can easily look up the things with clarity because I'm using these specialized plate. So I'll just show you the assembly. See, now this is very, very important how this assembly is looking up. Yeah, see, we have a cathode, okay, a photocathode here. Then we have a photo multiplier, and then we have a phosphor screen. Okay, and after from that phosphor screen, then you are taking up the vision. You're getting the vision, or you're looking into it. Now, understand what is happening overall here is that you are getting light captured in, okay, the image is captured and that is recorded on the cathode. Then you have photo multiplier where the quantum count is increased. You know that it's a type of amplification. Okay, so you are increasing the amplification. Okay, so what you're you're increasing the electron count. Okay, the electrons, they are increased because this photo multiplier. Okay, and this enhanced electron beam is when made incident on the phosphor screen, you will get the vision. Okay, you will get the like you can see whatever object is there, you can see it with clarity. There is a tree, or there is something like a house. Okay, so this is very important for people who are carrying out these secret mission or the night operations, like the military people or the security people. They find it very, very helpful, because for them to carry out an secret mission or such operation, they cannot use light from anywhere. What they have to do is they have to use such objects which can give them a better clean vision. Okay, because for them maintaining this darkness is important. Okay, then only they can carry out their secret mission or secret program operation, that whatever they are carrying out. So what you can see here is that we are using cathode. For what purpose we are using? Photons are entering. Okay, and you have the electron developed from the cathode. Okay, this electron beam is amplified by the photomultiplier. So photomultiplier is increasing the electron count. Okay, and this amplified beam is now striking the phosphor screen. So phosphor screen is giving you a visible light emission or a specialized light emission. Okay, which will make you to see the object clearly. Okay, so this is entirely the process is all about. And what is very crucial here is this phosphor screen. Okay, because phosphor screen is capable, like you have seen, the night vision devices have this green type of vision. Why this green color vision or green monochromatic you are getting vision? Because see, they are using green phosphor, okay, or white phosphor for sheets. Okay, so they are using those specialized material that gives you green light emission or white light emission. So that's why the vision that you are getting there is having that green chroma as the dominant one. So what you are recording, what you are getting is this green color images. So you must have seen in many movies it is shown, or in the workshop that you have attended for night vision devices, or somewhere if you have seen it, you have seen that they will give you that greenish vision just because of the phosphor plate that we are using. Okay, so we are using that phosphor plate, and that phosphor plate is the one which plays very important role, because amplification is done, but phosphor plate gives you a enhanced vision. Okay, a clear vision. Okay, so this entire assembly is created in such a way that a better vision can be obtained. Then coming to ScanX. Now this is ScanX is very interesting application, and I have seen personally have seen few of the clinics in Delhi also, they have started this ScanX, which is very interesting. See, there are specialized plate. We call it as photo stimulated phosphor plate. Now let me explain a little bit about them. Then you will find this as very interesting application. See, PSP, like I just want to say that phosphor responds to, or these nanophosphor you can say, or the phosphors you can say, they respond to specialized energy. Like you are giving some energy And what happened when you are subjecting energy on them, you will get the emission. Okay. Now, how this characteristic is used? Now, the source of your energy, it could be any source. It could be your mechanical source, you like mechanical energy you are supplying. It could be thermal, it could be any chemical, it could be an electrical impulse. Okay, so taking up photon as one of the energy source, if you supply some amount or like some particular photon of some particular wavelength on your phosphor plate, and you will get a different emission, then you are talking about photostimulated luminescent material. So stimulated luminescent material is stimulation. It is very important to understand this word. What is happening is you are supplying some type of energy from outside, okay, which is in photon form. So it could be any energy, and you are supplying that energy, so your plate get illuminated. Okay, now what is how this technique is used by these orthodontist, endodontist, oral surgeon, that I'll explain you. Like we take x-ray. Okay, there are specialized sheet. Similarly, PSP are the sheets, or PSP are the plates where the data is recorded. Now when data is recorded, it is kept preserved, and this data can be read then only when you are giving light as the stimulation. Okay, stimulation is a stimulus. Okay, something provided from outside. So PSP include photostimulated phosphor plate. So for example, I have to take like as a dentist, I want to take the like a you can say that a image of a broken tooth of one of my patient. Now what I am doing is I am using PSP as the recorder. Okay, now I have taken the image, PSP has recorded the image. This image is there with the PSP, it is conserved there. Now when it will be read out, when we will read out it, we will read it out when we are supplying light from outside as the stimulation. Okay, so photo stimulated phosphor plate. Okay, so what this entire system is like, what is the positivity or the positive point? First of all, wireless. Okay, so this, if you see in the image, you can see clearly see in the slide, the small black plates kept. Okay, these are nothing but the PSPs. Each PSP is having some data recorded in it. Okay, now this data is there with us. The PSP are conserved, the like data is conserved in the PSP. It is wireless. First of all, it is fast. Okay, quickly that image is recorded, it is conserved safely, and it could be read out more safely. Okay, comprehensive, affordable, and easy to use. Okay, so this is like Scanex. If you see this machine, this name is Scanex is given just because it's just a scanner. Okay, it will scan, it will record the image is recorded in the PSP, and then it will be read out. So all the pedodontist, orthodontist, endodontist, oral surgeon nowadays are using this technique. It is very interesting technique. And just like I have quoted in the earlier discussion, that you have holography. Okay, now holography is having a process. What are the process? Recording, preserving, and reconstructing. Similarly, phosphor plates are also having this characteristics that you record, you conserve the data, there is nothing going to happen to the data, and it's then you read it out, okay, or reconstruct the data. So for that you use, because it is photo stimulated phosphor plate, so you have to use photon only as the stimulus. Now there is one more thing which is important. I want to quote it here. Generally, when now you are using a phosphor or nanophosphor for recording the data, right? So you have to use those phosphor which can keep it preserved for a longer time. Okay, so the fading characteristics are very important. if you have a material that fade out, means the information or the data that is recorded, it declines with time with a faster rate, then you are not using it. Okay, then you are not using it. You are always using those materials or those plates which have a long they will long lasting, or they will have a less fading characteristic, a low fading characteristic, because if they fade out early, your data will not be conserved for a longer time. So selecting a nanomaterial, selecting a particular material for any application, it needs a lot of research. It needs a research, not in term of the dimension, because if you are talking about material which is having a small dimension, then you have to choose the chemical composition according to that. Or if you are talking about a material which conserve the information for longer period, you have to choose it accordingly. You have to choose a material which have low fading characteristic. So nanomaterial, there is so much to research, there is so much to know. And like every time when you are researching and you are working on their characteristic, you will come across more and more interesting applications in which you can use them. Now, coming to the next one. These are some of the recommended references that I included while I was preparing this discussion, and I've basically focused on these interesting write-ups and books. So there is a lot about nanotechnology. You can also get many other good books, but these are some from my bookshelf which I want to quote. And thank you for the attention. If you have any doubt, if you have any query, you can ask me.
Thank you so much, ma'am. It was really informative and incredible session. So now it's time for Q&A, questions and answer round. So if anybody is having any questions, they can type in the chat box. If anybody is having any question, they can type in the chat box. Okay, ma'am, there is one question. Ma'am, what less fade time means reusability?
Of course, it means reusability because data is erased. But see, it's also important how long you want the data to survive. Okay, for example, I want the data to survive like for a longer time. I would prefer a material which have less fading time, because if it's fade out so early, I mean, how can I preserve the data for a longer time, right? But yes, if it fade out early, you can reuse the plates again and again. Like PSP plates are there, you can use them again and again. You can again record another data. So reusability is definitely a plus point. But what is an important point on the other side is how long you want the data to survive. For example, I have a confidential data which is important for historical purpose. Now I don't want this data to decline ever. I want it to keep forever, right? So I will choose a material which is such so good enough that it will survive for a longer time, right? So it's just about the priority. You want reusability as a priority, or you want data conservation as the priority.
Thank you so much for your insights, ma'am. Ma'am, there is another question. What
Yes.
are the application of nanomaterials in mining industry?
Okay, in mining industry, see, mining industry, nanomaterials, basically you are, if you are talking about the mining industry, then nanomaterials are important when you have them rare, combined with rare earth. Okay, if you are using rare earth doped or rare earth activated nanomaterial, their mining is very important, because rare earth are like the name suggests, they have a less abundance. Okay, so it's not so easy to get them. Their mining plays a very crucial role, because you are getting it from a mining purpose, from mining sources, and it takes a lot of you can say very difficult process of getting a pure rare earth, because purity matters. If I want to make a material, I want it to be 99% pure. Like 100% is ideal. There's nothing like 100%. What we always get is 98, 95 or 99%. So mining is important because mining gives you a opportunity to get materials that are good in quality. Okay, there is a lot process of uh, mining that involves like getting the pure format, and then you are using it. And nanomaterial becomes important because when you are using rare earth activated materials, okay, nanomaterials, they gives you the clarity in visible emissions, okay, or UV or IR emission.
Okay, I hope the answer is like the question is answered. Okay, so ma'am, there is another question. Is it difficult to synthesize hidden ONP by biological method?
I won't say it is difficult. No, it's not difficult, although it is sophisticated. Like the entire setup that you are developing, you have to keep three things into mind. Because see, laboratory synthesis, and when we talk about the some synthesis on commercial basis, what is important is when you are talking about commercial basis, you want it to be economic, right? So in laboratory, if you are putting up so much effort in sophistication of the synthesis, okay, if you are keeping so many things intact together, somewhere there is complication in getting the material extracted. Also, there is the ease part of synthesis is compromised. You are not getting that ease in getting it. So only the system and the setup is complicated or little sophisticated, but it's not difficult, I would say. We need to work more on easy methods.
Okay, so ma'am, there is one more question.
Okay.
Ma'am, can I use nanomaterials in wastewater treatment? Which one will be the better, ma'am?
Okay, wastewater treatment, yes, you can use, and it's basically like there are specialized purification filters that we are using. Okay, now purification filters, they will confine a particular dust or a particular type of like you have some contamination in water. There you can use these filters. Okay, so only thing is that you have to choose the material very wisely, because water treatment should have few things in mind. There should not be a reactivity of your material with water, okay, because a reactivity with water will develop something else. So water treatment, if you are carrying out, the material should not be reactive with water, first of all. Also, how you are using it or how much purification it can give you, that plays a very important role. So you have to take that into mind, and you can definitely, yes, you if you go and you can search about the categories of materials that can be used for water treatment, there's a huge number of materials that can be used for water treatment. But always water treatment done with nanomaterials should be kept two things in mind: the purification, to what extent you can get, and also the reactivity. The material should not be reactive with water or the combination of water that we are getting, because in water we have many other salts present, many other elements present. Okay.
Okay, thank you so much, ma'am. There is another one more question.
Okay.
So, since we can make nanomaterials from breaking big one to small and adding up small to big one, that is two approaches. What is the magical thing about the nano dimension which is not shown by big or small materials?
I mean, just read out once again. I have to understand the question. He's telling about bottom and top approach, right? He's telling about my two approach. Now, what is the question after that?
Okay, ma'am, I just read out
Okay.
the full question.
Okay.
Since we can make nanomaterials from breaking big one to small and adding up small to big one, that is two approaches. What is the magical thing about the nano dimension which is not shown by big or small materials?
Okay, see, nano dimension, the important or the magical thing is that, first of all, nano dimension does not give any distinction, because there is no limit. to, like, there is no limit to what nano you can do. Like, I am taking an example. For example, I have said this I have synthesized a material and this is the dimension. Now there is a scope to go for a material which will have more smaller dimensions. So the magical thing is that this line that I have quoted in the beginning, which Richard Feynman has said, this line is the backbone, that there is plenty of room at the bottom. If you are going to the bottom, there you will see a lot of scope. Then you are going to much smaller dimension, you will get more scope. So this scope is unending, and it does not matter which is, whether it is bottom up or top down. What's important is that nanomaterials has meliorating properties, like if you are changing their dimension by very minute, or you are varying the temperatures, like the temperature on which you are synthesizing, or the method of synthesis, or you are developing structured, like specialized structure. With every small change you will see a drastic change. This what I have found even while I was doing my research. I found that this is very, very important. Like if you are doing a little change, you will see a big effect.
Okay, so ma'am, thank you so much. And there is one more question. Okay. So, okay, can you give an example of the application of nanotech in agriculture sector?
Nanotech in agriculture sector, see, I have not that much idea with that nano, but yes, definitely I can say that the farming materials that you are using, especially when you are talking about the seeds, okay, or you are talking about like you right, nowadays what we'll find that people are trying to uh, synthesize or prepare different material in their fields, okay, not the conventional one. You are using crops that are crossed crops, okay. So there also, if you think about synthesizing a material in lab, you can combine two different things together in the nano dimension, okay. For example, I have A and B, two different crop, and I want to get a immediate one, or a combination of the two. So this you can carry out at nano scale. You can see how it is possible, okay. And when you are carrying out that, with this you can get an idea, and you can execute the nano dimensional study for higher scale, or for commercial or a big scale, okay. So research is, of course, you have to do the research in lab, you cannot do the research in field. But agriculture is not my area, so I confine myself to this discussion only.
So ma'am, would you like to take few more questions?
Yes. Okay.
So there is one more question, that is, I'm trying to make protein-based nanomaterials, and its size is in micro. Actually, I have a problem to colloidal state of nanomaterials. It is always goes to settle down. This make harder to the characterization techniques. Like I can't do DLS.
Okay. Yes, this is a problem. This happens. Okay. Even you need to work more on your material, in the sense you can vary the synthesis technique, because when I was working, I have also found that there are some materials that have a problem with their dimension because of the synthesis technique. So I would suggest you to vary synthesis technique and look up these techniques that have more probability of getting you nanomaterials, okay. And this colloidal part is also an issue, but it is basically the material characteristic. So maybe a combination of the chemical could be varied. For example, there are certain materials that are you can see their solubility in one combination, and in another combination it is not possible. Like they are not showing you the solubility or colloidal state. So colloidal state problem also, you have to work with the compound of sisters, like sister states. For example, calcium, barium, strontium. If I'm talking about the zirconate, now this CaBaSr is a sister family. Okay, so maybe I'm not getting colloidal or this micron size for calcium zirconate. So I can try its sister family, and I can try different synthesis route. There I can get it done, because synthesis route is very important. Like if you are doing high temperature technique, the nanomaterial that you are trying to synthesize will come up to micron. There are chances of getting into micron. But when you come to low temperature technique, it will become easy, and it will come to nano dimension very easily. So I think this would be my side of suggestion.
Okay, ma'am. So I think next question is, can nanomaterials are also prepared by mercury, which is a liquid metal?
Mercury based, yeah, we have mercury based nanomaterials, but it just depend upon like what is the like application for which purpose you are using it. Mercury based materials are also there. Even in some of the cases we are using mercury as the added impurity also, so there is no problem with using nanomaterial having prepared from mercury, or mercury is added into the host lattice, so there is no problem. Only you have to like what purpose you want, or what you want, you want nano powder, or you want a thin film of nano material, what you want, that need to be in mind, then only we can work with the chemical combination and the synthesis route.
Okay, so I think, ma'am, we are done with the questions from audience side, and
Okay.
still we'll wait for 1 minute. If anybody is having any question, they can type in the chat box.
Yeah.
Okay, I think, ma'am, we are done with the questions.
Okay.
So we should move further. Thank you so much, ma'am, for answering the question very patiently and clearly. Thank you so much, ma'am, for making this session a big success. The webinar was really amazing, and I would like to propose a hearty vote of thanks to you, ma'am, for gracing today's webinar. Your presence and wise words help magnify our cause in best possible way. I hope all the participants learned a lot from this webinar. I would really like to thank you, ma'am, for giving us your valuable time, and I'm also delighted to be a part of today's session. A hard beginning makes a good ending. All good things eventually end. I consider everyone a fortunate that they become a part of today's webinar, which was full of knowledge and which makes difficult to say goodbye. Before signing off, I request everyone to please fill up the feedback form, which is provided in the chat box, and you can fill the feedback form within 24 hours after the session, through which you are able to get your e-certificate within 15 working days. And remember, don't forget to subscribe our YouTube channel and attach the screenshot as a proof in the feedback form. Also, tag us on your Instagram handles with the hashtag DIGISAKSHAM along with the certificate screenshot of your certificate in your stories. So kindly fill the feedback form.
So I would also like to thank Vandana and your team, and it is really a wonderful, and I would also like to thank the participant for asking interesting questions and for their active participation. So thank you so much.
Thank you so much, ma'am. So moving ahead, I request everyone to please switch on your cameras so that we can take a screenshot. Ma'am, can you just please stop sharing
Okay.
so that we
Just,
can take screenshot of our participants?
yeah.
Yeah. Everyone, please open up your cameras. Thank you so much, everyone, for your cooperation. Again, thank you all for attending today's webinar. And if you have additional questions, you can contact us by email or telephone. We are happy to provide additional support to you. Better is not good enough. The best is yet to come. I, Vandana Garg, your host for the day, signing off on a cheerful note. Have a wonderful day. Thank you so much once again. Thank you so
Thank you.
much, ma'am, for joining us today.
Thank you, Vandana. Thank you
And
so
thank you
much.
so much, the audience. Thanks so much.